Okay, I welcome you members in this session, the Senior for Chemistry online class. Always teacher St. Joseph Robert, St. Andrews Matale SS, Kalisto Chotera. At this time round, we are going to look at industrial processes. Industrial processes. At this time, we are going to stick on extraction and the purification of metals. And generally, extraction of metals metals are extracted from their ores, and an ore is a naturally occurring rock in which metal is to be extracted. So to extract metal, we need to know what is an ore, and for further information, you can use video. Videos are linked in our slides. You can look at the video. You can tap in the link for further study and for further definition, further information about the description of an ore. So generally, metals are extracted from their ores, but we have talked about the introduction about industrial processes, and we spent our time there when we get introduction about industrial processes. So when we are extracting metals, there are steps involved in extraction of metals. But when we are considering those steps involved in extraction of metals from ores, we need to know the reactivity of the elements on the reactivity series. Elements reacted differently and are represented on the reactivity series. The reactivity series is helping us to know more about the way our metals are reacted. So we are extracting metals, and these steps involving the extraction of metals from their ores are generally considering, we are considering the reactivity series, reactivity of the elements. These steps These steps include ore concentration, reduction, refining. As we are seeing our chart here, our chart describes these steps, and we have the links which are embedded in the slides. You can tap in the link for further study. And as we said that, we are considering when we are considering those steps, we are considering the reactivity of the elements on the reactivity series. Here we have our reactivity series. We are saying that this specific method depends on metals reactivity, as we said before. Highly reactive metals are extracted by using electrolysis, and those metals, we are seeing them here in our flow chart on our reactivity series. Those metals are potassium, sodium, calcium, magnesium, and aluminium. For them are extracted by electrolysis, and moderate reactive metals are extracted by reduction with the carbon or other agent. Carbon is a reducing agent, can reduce metals which are lower than it in a reactivity series. That's why moderate metals are extracted by reduction of carbon, and these are zinc, iron, tin, lead, copper. And the least reactive metals occur as free metal in Earth's crust, and these are silver, gold, platinum. For them, they are naturally occurring metals, and they dug from Earth when metals. So you can tap in the link. Each slide has the link. Each slide embed the link where you tap and you read further information about that slide. So let us now, we have seen steps involved, we have seen further information. You have looked at further information from the link, Now let us see how to extract metals. Let us start with the copper. This is all of copper in the picture, and these are the raw materials used to extract copper. Raw materials we have copper pyrite, we have silicon dioxide, we have oil, acidified copper to sulfate solution, and the main raw material is copperite, which is an ore where copper is to be extracted. The other materials are agents, third parties to extract copper from its ore. But the main material is ore, which is called copperite, and this is the formula for copperite, which is the chief ore from which copper metal is extracted, containing impurities such as silicon dioxide. But that is not only ore in which copper to be extracted. There are other ores, and the list of ores of copper you will tap in the link. You tap in the link, and you use this link source to access list of copper ores. Then another step after raw material is the process of production, process of extraction. Process of extraction, we talked about steps involving in extraction. Those were concentration of ore. Let us look at concentration of ore when we are extracting of copper. Concentration of ore is all about crushing, preparing ore into powder form, such that when you feed it in blast furnace, can be reduced, the powder can be reduced. So let us see concentration. The ore is crushed and ground to fine powder, mixed with the oil and the water in a steel tank to remove impurities. Again, compressed air is blown through mixture in a tank, a process called flotation to ignite the mixture. We are seeing that one in our diagram, in our support material. Here, this is the frothing process, the one which you have put here. Oil-coated particles of the ore float on the top of the tanker and are skimmed off and dried, which is this froth. Then here is what? Here is skimmed off, where to be dry, where to be dried. What else after? We are going to find the reduction and the roasting process. Reduction and the roasting process. Reduction and the roasting process is where copperites are roasted in furnace from copper 1 sulfide to iron to oxide and sulfur dioxide, as showed as represented in the equation below. Then silicon dioxide is added to furnace, where it reacts with iron to oxide from this equation. Remember this copperite. Now it was crushed using the other method of concentrating ore, and we get powder. Then after getting powder, then we feed it in blast furnace, in the furnace where it is heated in oxygen to produce copper 1 sulfide and iron to oxide. Then this is silicon dioxide. Silicon dioxide is added to the furnace where react with the iron 2 oxide to form iron 2 silicate, slag leaving behind the copper 1 sulfide, as equation below. This information is brief, but you can play video here and you see how to extract copper using this video. Or you can go to the link. You can visit this link for further information. Another step after we have purification. Purification, remember we have crushed, concentration process has done. Concentration process has done. Then reduction process has done. But now we are looking at purification. What is the purification? Remember, the reducing or frothing process, it was all about getting iron from the ore. But iron we got from the ore, it contains impurities, and those impurities are removed by purification process, where we use electrolysis method. Impure copper is purified by electrolysis using copper as anode and pure copper as cathode in electrolyte cell containing acidified copper 2 sulfate solution as electrolytes. As we talked about it in electrolysis, remember we talked about it in electrolysis chapter, where we talked about oxidation and reduction. Is where we talked about electrolysis. So now at this time we have the idea about electrolysis. Therefore, impure copper dissolves to form copper 2 ions, and the pure copper is deposited at cathode. Then equation at cathode, copper ions are deposited at cathode, and this is pure copper is formed. Our aim is to extract copper, to get pure copper, and this is now our desired product. Desired product now is pure copper. And what happens at the anode? At the anode, copper goes into the solution as copper ions, whereby at anode, the anode will decrease in size because it keeps dissolving, as we are saying in our support material. Then further information you can visit these links. We am always embedding the links where you tap and you get further information. Remember, after extracting, we have what we call, we meet many challenges during the extraction. Those are impacts. But remember, when you meet any impact during the process, you must get the way how to mitigate or to solve that impact. We have environmental impacts, as you are seeing in the picture. These are impacts. We have environmental impacts, we have health impacts, and so on. But if you need more, you will tap in the link and you get more impacts. Now, after impacts, our desired product has the benefit. We processed that desired product to benefit the community. Now, meaning that we need to talk about social benefits of that desired, of the process of production. How the people benefit in the process of the production. They got employment, as you are seeing. They get jobs. Economic growth, development of infrastructures, as you are seeing in the picture support, and the further social benefits. You will tap in the link, and you get further social benefits. Then that is copper. Generally, that is copper. Further information, you will visit the links, and you use other digital tools to meet other more information about extraction of copper. Now we are looking at extraction of iron. Remember, we have many metals to be extracted. Within this session, allow me to stop with the extraction of copper. Now, next session, we shall look at extraction of iron and extraction of aluminium. Thank you for watching. I'm remaining teacher Sendios Robert. of St. Andrews Matale SS Kyotera Kalis Zone,